Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International A-Level Mathematics Paper 3, which is a pure Mathematics 3 for May-June 2019, and the code is 9709/32. So let's move on to question number 1. For question number 1, find the coefficient of x cubed in the expansion of 3 minus x times 1 plus 3x to the power of 1 over 3 in ascending powers of x. Okay, so here I will just rewrite the question. And then I will just do expansion to get the coefficient, right? So this is 3 minus x. Now for the expansion, so please refer to the formula 1 plus x to the power of n. It will be 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 n minus 2 over 3 factorial x cubed, and then until infinity terms. So from here, I will be getting 1 plus, my n is 1 over 3. Then the x is 3x. Okay, plus, then 1 over 3. So 1 over 3 minus 1 is basically negative 2 over 3. Then over 2 factorial 3x squared, because you need to get x cubed and there is a 3 here. This is a constant. That means we need to expand until x cubed. Okay, because the next term is already has x, means that we just need to multiply this minus x with x squared. So in general, my expansion must be up to x cubed. So minus 2, what here? Minus n times n minus 1, n minus 2. So now the minus 2 over 3, you minus another 1, that is minus 5 over 3. Then over 3 factorial, then 3x cubed. Okay, so from here, I will simplify the terms inside the square bracket. You will be getting 1 plus x minus x squared plus 5 over 3 x cubed. Okay, then from here, to get the coefficient of x cubed, so for this 3, I need to multiply with 5x cubed in order to get x cubed. Okay, and then for this minus x, I need to multiply with minus x squared. But then since I'm writing here coefficient, means that I will ignore the term of x cubed. So that means that is 3 times 5 over 3. Then minus 1, because of minus x, times the minus x squared. That means it's another minus 1. Therefore, I will be getting 5 plus 1, that is 6. So that is the coefficient of x cubed in this question. Okay, question number 2, showing all necessary working. Solve this equation. Give your answer equal to 2 decimal places. So now 9 power x equals to 3 power x plus 12. So the 3 power x I can move to left side. So it will be 9 power x. This 9 and 3 I can change to 3 squared equals minus 3 power x minus 12 equals to 0. Okay, so we have a formula here, a to the power of m, then another degree n here. This is a to the power of mn. So it means that the first term is basically 3 to the power of 2x. Then second term, just rewrite, and same goes to the last term. Go from here, I will say that I can let u be 3 power x. That means, okay, 3 power 2x is basically u squared. Then I'm getting a quadratic equation. And this quadratic equation can be factorized into 2 linear factors. To get u squared, that is u times u. To get look at here, the sign here, minus times plus is a minus, right? Therefore, I will have 1 minus and 1 plus. So now to get 12, and here is minus, therefore it will be minus 4 and plus 3. Because when I multiply, this is plus 3u. So minus 4 times u is minus 4u. So the middle term, when you add up, it will be minus u, which is same as the middle term. And here is u squared, lastly minus 12. So now for the factors, it will be just cross multiplication. Then you will be getting u minus 4 times u plus 3 equals to 0. Then from here, either u equals to 4 or u equals to minus 3. Okay, when you solve these two equations. Now, since my u is 3 power x, so I will just write 3 power x equals to 4. Okay, or 3 power x equals to negative 3. Now to get the x, you need to take ln both sides. So ln 3 power x is ln 4. And then use the formula of the ln. Ln a power b is b ln a. Alright, so I can factorize the power. So it becomes x ln 3 equals to ln 4. Therefore, my x is ln 3 over ln 4. And now, 2 decimal places, that is going to be 1.26. That's the first x. Now, when you take ln, okay, ln negative is error. So this is undefined. Alright, so that's all for the working of this question. Okay, question number 3, showing all necessary working, solve the equation for theta between 0 and 180 degrees. So from here, cotangent 2 theta is 2 tangent theta. Now we know that cotangent 2 theta is 1 over tangent 2 theta. Alright, so this tangent 2 theta will be moved to the other side. So 1 equals to 2 tangent theta multiplied with tangent 2 theta. Now use the formula of tangent 2a, the double angle formula. Tangent 2a is basically 2 tangent a over 1 minus tangent squared a. Then now my a is theta. Therefore, I'm getting 2 tangent theta multiplied with 2 tangent theta over 1 minus tangent squared theta. Okay, and now here, basically for this denominator, I can just move to the other side, becomes times. Therefore, I will be getting 1 times 1 minus tangent squared theta. Then right hand side, it will be 2 tangent theta times 2 tangent theta. Okay, then from here, you will be getting 1 minus tangent squared theta. Right side is basically 4 tangent squared theta. So then from here, I can just group the terms with the tangent squared theta. So move the minus tangent squared theta to the other side, becomes plus. End up with 5 tangent squared theta is 1. Okay, then from here, I will just write my tangent squared theta is 1 over 5. Therefore, my tangent theta is plus minus square root of 1 over 5. Because of the interval, okay, look at the theta here. Your theta is from 0 to 180 degrees, right? That means it is between 0 and 180 degrees. That means it will be in first 2 quadrants. So when first 2 quadrants, your tangent will be positive and negative. So now I will get the basic angle. Basic angle is basically inverse tangent square root of 1 over 5. And then you will be getting 24.1. So that's why I label my basic angle. So now my theta is basically first value 24.1 and second value is the major angle. So therefore I will write 24.1 degrees and the other one is 180 minus 24.1 degrees. And then at last you will be getting 24.1 degrees and 155.9 degrees. So that's your solution of this question. Okay, so for question number 4, find the exact coordinates of the point, that means only one point, on the curve y equals to x over 1 plus ln x, at which the gradient of the tangent, so gradient of tangent or just simply gradient, that is basically dy over dx, is equals to 1 over 4. So it means that before I substitute my dy dx equals to 1 over 4, I must have found my expression for dy dx. So this is basically division of two functions. So therefore, refer to the quotient rule. Differentiate u over v is going to be over v squared vu prime minus uv prime. Okay, which means now my u is x, then my u prime is 1, and then my v is 1 plus ln x. So my v prime, differentiate 1 is 0, differentiate ln x. Okay, another formula to differentiate ln fx, that is over fx. So differentiate fx, f prime x. So which means I will write over, okay, because when you differentiate 1, you get 0. So actually we are differentiating ln x. So here it will x, differentiate x is 1. That is your v prime. Okay, so it will be just simply 1 over x. Now, my dy over dx equals to over square of 1 plus ln x. So rewrite the denominator and multiply with the 1. Okay, then minus, keep the u, that means it's the x, v prime will be 1 over x. So from here, you will be getting 1 plus ln x minus 1 over 1 plus ln x squared. Okay, so the 1 and minus 1 cancel off, means that your dy dx is basically ln x over 1 plus ln x squared. And now you are given dy dx equals to 1 over 4. Okay, so now just replace. So you just write here, given dy dx equals to 1 over 4, which means 1 over 4 equals to ln x over 1 plus ln x squared. And now here I will cross multiply. Okay, so when cross multiply, you will be getting 1 plus ln x squared equals to 4 ln x. Okay, the question asking for exact coordinates of the point. That means you need to find out the exact value of the x. So from here, I will do expansion for the quadratic. So that is a plus b squared. Then you will be getting a squared plus 2ab plus b squared, which means you will be getting 1 plus 2 ln x plus ln x squared. Then the 4 ln x will be moved to left side. So it becomes minus 4 ln x equals to 0. So now I rearrange it so that it will be in the quadratic form. So first term becomes square of ln x. Now the second term is basically 2 ln x minus 4 ln x. So you will be getting minus 2 ln x. And then plus 1 equals to 0. Okay, then from here, I will just say let u equals to ln x. That means I'm getting u squared minus 2u plus 1 equals to 0. This, when you simplify this or factorize this, this is basically u minus 1 squared. Alright, so which means u minus 1 equals to 0. So then u equals to 1. Now to get the x, substitute this u into your u equals to ln x, which means ln x is 1. Now to eliminate the ln, okay, ln a, what to do is we add on the e. So because e ln a is a itself. Alright, so therefore from here I know that e ln x equals to e degree 1. That means my x is e. So, but then the question says we need to find the coordinates of the point. Okay, therefore, you need to calculate the y. Just substitute back into this expression, x over 1 plus ln x. So, y equals to x over 1 plus ln x. That means this is e over 1 plus ln e. So, ln e is basically 1. Okay, this is 1. So, that means the denominator is basically 2. Okay, therefore, the point equals to x is e, y is e over 2. So that is the exact coordinates of the point. Okay, next question, number 5. Throughout this question, the use of calculator is not permitted. So it's given complex number minus 1 plus square root 3i is a root of the equation. The root here means the variable. That means this is the x. Right, write down another root of the equation. So since your root is a complex number and all these are constants, see, real constants, which means, okay, the conjugate of this complex number will be the other root. So another root equals to the conjugate of the complex number. So the conjugate, we just change the imaginary part from positive to negative. The rest remain. Okay, now part 2, find the k value and the third root of the equation. So when you need to find the k value, means that basically we are substituting this root into the equation. Okay, that means this is the x. You need to replace the x in the equation by the complex root. So here I will write x equals to minus 1 plus square root 3i. Okay, the equation is basically just copy back kx cubed plus 5x squared plus 10x plus 4 equals to 0. So replace the x by the complex number. Okay, now for the first one, because of power 3, you need to do expansion. So you may refer to the Pascal triangle just for information. Okay, so if let's say a plus b degree 0, you are getting 1. So I will just write down the coefficient of the terms. A plus b degree 1, that is a plus b. Okay, look at the coefficients, 1a, 1b. So here 1 and 1. So the idea is basically you add 1 at the front and back. So the middle one is just plus 2, plus together. So then, therefore, a plus b squared, it will be a squared plus 2ab plus b squared. Because of the coefficients will be 1, 2, and 1. Okay, so with this, I will just say the next one is going to be add these two together, that is 3. This is also 3. So basically, I will get, right, so here, minus 1 cube, because according to here, this one must be first term's degree with the highest degree. Then after that, the next term with the coefficient here, and at the same time, you decrease the degree of first term and increase the degree of the second term by 1. So therefore, I know that my next coefficient is 3. So I decrease the degree of minus 1 by 1 becomes 2. Then I raise 1 degree of the second term. Followed by 3 minus 1 degree 1 square root 3i degree 2 plus square root 3i degree 3. Okay, now for the second term, that is the quadratic expansion. So I will just write a plus b squared equals to a squared plus 2ab plus b squared for this expansion. So that is going to be plus 5 bracket. Okay, so minus 1 square is 1. I will just direct write 1. So when you multiply and times 2, it will be negative 2 square root 3i. Then you plus, you square the square root 3 is 3. You square the I, that is I squared. Okay, then after that, just do expansion for the next term. Then I will be getting minus 10. Then plus 10 square root 3i. Lastly, plus 4, then equals to 0. So from here, I will get k multiplied with minus 1 cube is basically minus 1. So minus 1 squared here, right? So when you simplify, this is 1. Then I will get 3 square root 3i. So you will be getting plus 3 square root 3i. And then for the next one is minus 1 times 3, so minus 3. But then you square the 2. Okay, so remember here, this squared bring in. So you squared the square root 3. That is 3. 3 times 3 becomes 9. Therefore, this is minus 9 I squared. Okay, lastly, cube of square root 3, that is 3 square root 3. So plus 3 square root 3i cube. Okay, then here, this 5 you move in. Okay, just times in to all these terms. So you will get plus 5 minus 10 square root 3i. And then this I square is basically minus 1. Okay, this is minus 1 because our important result, I square is minus 1 from complex number chapter. So that means this is going to be minus, okay, this is going to be minus 15. And then minus 10, okay, here, minus 10 plus 4, that will be minus 6. Then plus 10 square root 3i equals to 0. Okay, now here, because we need to find a k, right? Therefore, you will write k, just multiply. So I will get, probably I simplify first. Now, for information, this is minus 1. Right, this I cube, look at here, I cube is I squared times I. Since I squared is minus 1, that means it's minus I. So I cube is going to be minus I. Therefore, alright, I will write minus 1 plus 3 square root 3i. This is plus 9. Then minus 3 square root 3i. Then the rest I will simplify. So 5 minus 15 is minus 10. Minus 10 minus 6. So you get minus 16. So then the 2 square root will be cancelled off. Okay, because 1 plus and 1 minus. Then from here, you will be getting equals to 0. Okay, then for the bracket, right, I will get 9 minus 1 is 8. So the square root together with the I will be cancelled off. So basically it's 8k minus 16 equals to 0. So it means that 8k equals to 16. Therefore, my k is 2. Okay, so this is the first part. Now you see the question said find the k. Now find the third root. So to get the third root, we need to get the polynomial division. Okay, because we know that now your the cubic function, look at the cubic function here, and replace the k by 2. You rewrite this and then we can find the factors. So from here I will say 2x cubed plus 5x squared plus 10x plus 4 equals to 0. And just now we are given 2 factors. Okay, so x minus, you are given 2 roots, I would say, given 2 roots. So probably I write down the factors first. So the factors equals to x minus, just now was minus 1 minus square root 3i. Okay, minus 1 plus square root 3i. So then you change to factor form. So that means this is minus 1 plus square root 3i. Then you multiply with x minus minus 1 minus square root 3i. Okay, then from here you do the expansion. So it means that x multiplied to the whole bracket and then followed by this multiply. So here I will be getting x squared. Then x multiplied with the minus of the bracket, that is negative of the bracket, then x. Okay, same goes to this part, this expansion. This is a negative, so negative x times the bracket. So then the last one, minus and minus is a plus. So complex number times conjugate. Right, look at here. Complex number times conjugate. So we have a formula. Complex number times conjugate. That is basically real part squared plus imaginary part squared. Okay, therefore, I will just direct change to minus 1 squared plus square root 3 squared when you do expansion. That means I will be getting x squared Okay, now when you look at here, this is minus 1x, right? When you do expansion. So let's say I just do expansion. That is minus minus is plus. So plus 1x. Then minus minus is a plus square root 3ix. And same goes to the next expansion. So minus minus 1 is plus 1. So minus and square root 3ix, it will be minus square root 3ix. So for the last two terms, 1 plus 3, that is 4. Okay, then from here, I notice that basically the term with the I can be cancelled off because 1 plus and 1 minus. So I only have three terms, right? So that means my factors will be x squared plus x and then plus 5. And now, to get another root, I need to perform the polynomial division, which means my 2x cubed plus 5x squared plus 10x plus 4 will be divided by this quadratic factor. Okay, let me check any calculation mistakes. Oh, okay, mistake over here. Look at here. Okay, this one when I times, this is 1. 1 multiplied with the x. Okay, my x is missing. This is not 1. This is basically x. Right? So, which means now my factor will be different. It will be 2x plus 4. Okay, sorry about that. Okay, so here will be divided by x squared plus 2x plus 4. So now to get 2x cubed from x squared, you have to multiply with you need to multiply with 2x. So here 2x times x squared, 2x cubed. 2x times 2x, 4x squared. 2x times 4, 8x. Then you minus. So 5x squared minus 4x squared, 1x squared. 10x minus 8x plus 2x. Then we write the plus 4. Now same degree for both x. Therefore the highest x is 2. The highest degree for the x is 2 now. Therefore you multiply with plus 1 to get x squared plus 2x plus 4. Okay, that means now my another factor is 2x plus 1. So another factor is 2x plus 1. And then the question is asking for root, okay, third root. So when the function equals to 0, that means 2x plus 1 equals to 0, right? Which means now here, when you rewrite, this is basically 2x cubed plus 5x squared plus 10x plus 4 equals to 0. That means you are getting x squared plus 2x plus 4 multiplied with 2x plus 1 equals to 0. So you just let the linear factor be 0. That will be your another root. So which means 2x is minus 1. Hence your x is negative half. So another root is x equals to negative half. So this is how we solve this question. So for question number 6, in the diagram, A is the midpoint of the semicircle. Okay. With center O and radius R, a circular arc with center A meets the semicircle as B and C. Okay, so here. Alright, so now the angle OAB is same as x radians is given here. The area of the shaded region bounded by AB, AC and the arc with center A, which means this shaded region, is equal to half of the area of the semicircle. Use triangle OAB to show AB is 2r cos x. So OAB. Alright. So now here, use triangle OAB. So OAB. So means that you need to join. Okay, and given this is x radian. So now what to do is, we know that this is r, this radius r, which means here is r. Okay, so probably I just use another color. You can see clearly. Okay, here is r, this is r, here is also r. Right, so it means that now, since the OA and OB are r, so I will be getting the isosceles triangle. So when I draw, okay, basically it's like this. OA, B, both r. So isosceles triangle, and here is x, radians. So now we need to find out AB. What is this? Alright, so from here I will say that both are right angle triangle. So here is also x because of the isosceles triangle. So I will say at A, okay, now I do not know what is this length, but that will be half of AB. Okay, so the x has adjacent side of half of AB, and then hypotenuse of r. So adjacent and hypotenuse is basically cos. So I will say cos x is half AB over r. Okay, then the r move up, then you get r cos x is half AB. And now we need to show AB. Therefore, just times the whole equation by 2, which means AB is 2r cos x. So we have done this part. Okay, part 2. Hence, show that x equals to inverse cos of square root. Now, hence means use the previous answer. Use this previous answer. That means here, right? And to show that, you need to make use of this. The area of the shaded region is half of the area of the semicircle. So now I will just write area of the shaded region is half area of the semicircle. Okay, so to get area of the shaded region, this is, we know that it is half r squared theta. Let's say this is the angle, this is the sector, this is the theta, this is r. So half r squared theta, that is the area of the sector. Okay, and now from here, we have found the AB. Basically, the AB is the radius of the sector ABC. Okay, so here we have found 2r cos x. This is our radius, and then the angle here is pi x. Is x, which means this part is going to be the same. That is also x. So I know that okay, you can just direct solve this, or probably you can just times 2. It's up to you. Alright, so then I will just write, probably I will just, because I know that it is symmetrical, then I will just find the sector. Okay, this sector, then I times 2. Okay, because AO is R, so OC is also R. Therefore, it will be symmetrical, same as the OB, right? Therefore, the AC is same as AB. So, okay, so I will just use the formula half r squared theta. So half, my r is the AB. So my AB is 2r cos x. My theta is x, and then I times 2. So x, after that I times 2. That is the area of the shaded region, half of area of semicircle. Now, circle is pi r squared. So half means half pi, and then what is the radius? Radius is r in the question. Therefore, I just write r squared. Okay, then from here, basically when you compare the left and right side, the half will be cancelled off. Okay, then now for the left hand side, I will be getting, okay, this is my r squared. Okay, this is my radius, so I should square it, half r squared theta. So this is 4r squared cos x, cos square x, and then there's another x outside, so I will just write here 2x. Okay, I combine these two together. That is my half pi r squared on the right side. And now you need to show this. X is inverse cos. Before you get the inverse cos, you must get cos x first, because this inverse cos can be moved to the other side. So which means here, okay, I can just move all the terms to right side except the cos squared. So which means I will write cos square x equals to pi r squared over 2. Okay, then the terms here, 2 and 4 becomes 8, together with the x and r squared. So all this will be moved down. That means it will be divided. So 1 over 4 times 2 is 8. Then xr squared. Okay, so obviously the r squared will be cancelled off. Okay, then now from here, I will be simplifying it into pi over 2 times x is 16. And then there is an x in the denominator. So now I will move the square to the other side first. So my cos x will be square root of pi over 16x. Okay, let's look at the question. So obviously your x here, okay, your x here is between 0 and 90 degrees, which is an acute angle. Therefore, when you take the cos x, it will be positive square root, right? It will not be negative square root because it is the acute angle. Therefore, from here, my x equals to inverse cos of square root pi over 16x. Now just check. You need to prove this. So we have proven the expression. Okay, so done for this. Number 3, verify by calculation that x lies between 1 and 1.5. So now I will refer to this expression and move the inverse cos to the other side. So which means my fx, okay, or probably I just rewrite first. So my x minus inverse cos square root equals to 0. So now I will let my fx be the left hand side. So to prove that it's between 1 and 1.5, so now you replace x by 1. Okay, so when you calculate this, make sure you calculate in radians mode. Okay, that means you will be getting negative 0.112. This is less than 0. And then followed by f 1.5. That is going to be 1.5 minus inverse cos square root of pi over 16 times 1.5. Then this will be 0.299. That is greater than 0. So refer to the sign change rule. f1 less than 0 and f1.5 is greater than 0. That is a sign change. Hence, your x between 1 and 1.5. Okay, so done for this question. Now, part 4. Use an iterative formula based on the equation in part 2 to determine x correct to 3 decimal places and give the answer of each iteration to 5 decimal places. So now I will refer back to the formula in part 2, which is this, right? But then to form the formula, we need to add on the subscripts. So I will write xn plus 1 equals to inverse cos square root of pi over 16xn. So now, since in the previous parts we have proven that x is between 1 and 1.5, therefore you can just take 1 or 1.5 or any values in between 1 and 1.5 as your x0. So I will take the middle value. So let x0 equals to 1.25. That means my x1, it will be inverse cos square root of pi over 16 times 1.25. This is going to be 1.16328. Okay, 5 decimal places. Now, when to stop for this iteration, you need 3 decimal places. Make sure you are getting same 3 decimal places. Then now here, I will be getting x2, that is inverse cos square root of pi over 16 times 1.16328. Then this is going to be 1.14742. Okay, then my x3, inverse cos square root pi over 16 times 1.14742. That is going to be 1.14432. Okay, so when you compare 3 decimal places, they are not the same. So it means that now I need to continue for x4. That is inverse cos square root of pi over 16 times 1.14432. Then this is 1.14370. So it's almost approaching the final answer. Okay, so let's do one more step. So this is going to be 1.4358. So now we'll compare. Miss out one term. It will be 1.14358. Okay, so now here I'm getting 3 same decimal places. Therefore, my final answer is based on last calculation and the next digit. So since next digit is 5, therefore I have to round up. So therefore, my x approximate to 1.144. So that is my solution of this question. For question number 7, the variables x and y satisfy the differential equation. Is given y equals to 0 when x equals to 0. First part, solve the differential equation obtaining y in terms of x. So now, dy over dx equals to x plus y. So to simplify this, first of all, I have to split the exponential x plus y into 2 terms by using the formula em plus n is basically em times en. Okay, so now I split first. This is going to be ex times ey. Then now I can just separate the variables. Since your dy is the numerator on the left hand side, so it means that all the functions of y should be on the left hand side. So this whole ey will be moved to the left side. So when I move, I will just write e minus y dy. Then right hand side you have x dx, at the same time integrate both sides. This is the separable variables method. Now for the exponential integration, so integrate exponential mx plus b dx, you just need to rewrite the exponential function. Differential mx plus b, it will be over m and then followed by plus c. But for the right hand side, since you have 2 terms here, this is going to be integration by parts. So u v prime dx equals to uv minus integrate v u prime dx. This is integration by parts. Okay, so your u is the x, and then the v prime is ex. So now your u prime is 1, your v is integrate ex. That is also ex. So now for the left hand side, using this exponential formula, I will rewrite that over minus 1 because we differentiate minus y, that is minus 1. For the right hand side, apply this by parts formula. It will be uv, so x ex minus integrate v du. So for the left hand side, since the e power negative y, I will move it down. So it will be negative 1 over ey. Then equals to x ex. Again, integrate ex, you get ex, followed by plus c. Okay, now to get the c, you need to replace the x and y values. So look at here, x is 0, y is 0. So which means when x is 0, y is 0, therefore negative 1 over e0 is 0 minus e0 plus c. Right, the first term is 0. The first term on the right side is 0 because of the x. So therefore, e0 is 1. You get negative 1 equals to negative 1 plus c. So from here, obviously, our c is 0. So now I will substitute this c into my previous solution. Then you will be getting negative 1 over ey equals to x ex minus ex. Okay, now look at the question. You need to get y in terms of x. So which means now I need to get my ey. The easiest way is just move up. Okay, so but before you move up, the right side you can factorize the ex. Right, so I can factorize ex, then here x minus 1. Then the ey move up and the ex move down. So here I will be getting ey equals to negative 1 over ex bracket x minus 1. Now, to make it nicer, because I don't want ex in the denominator, so you can just move up. Once you move up, it will be negative e negative x, then over x minus 1. Okay, this is your function. Then to get the y as a subject, you can just take ln both sides. Okay, and at the same time, this minus you put down. Okay, you times into the denominator. This one bring down. So then it will become ey equals to e minus x over 1 minus x. So then you take ln both sides because ln ea is a. Okay, so this is the way to eliminate. So ln ey, it will be ln of e minus x over 1 minus x. So for the left hand side, I'm getting y because of this formula. For the right hand side, I have another formula because I noticed that the ln e minus x can be simplified. But then ln a over b is basically ln a minus ln b. So I split it into 2 ln first. Then the minus x can be brought down. Okay, for your information, we have this formula. Ln a power b is b ln a. Then ln e is basically 1. Okay, then here negative ln 1 minus x. Basically, your y is minus x minus ln of 1 minus x. So this is the solution for this question. Okay, now part 2, explain why x can only take values that are less than 1. Okay, now look at the y here. Okay, I will rewrite this. Y equals to minus x minus ln 1 minus x. Y equals to minus x minus ln of 1 minus x. This is your y. Okay, how do I know the x can be only less than 1? So look at the ln here. Ln 1 minus x. Okay, so for ln 1 minus x to be defined, when you refer to the ln graph, right? This is ln x. Your x is always greater than 0. Okay, which means your ln x, so I would say the x must be greater than 0. Okay, x must be greater than 0. This is from the long graph. So for here, I will know that 1 minus x must be greater than 0. Therefore, minus x is greater than minus 1. To get the x, you times minus to this inequality. Then you have to change the sign for the inequality. Okay, so this is the reason. Okay, now for question number 8, given fx, find the partial fractions. So now I will rewrite the function first. So first of all, when you check, the highest degree of the numerator for x is 1, but the degree of the denominator, this is already squared. Together with x, it will be degree 3. So it means that you are given the proper rational function. Therefore, you can just direct find the partial fractions. So this is going to be a over 2x plus 1 plus b over 2x plus 3 plus c over 2x plus 3 squared. Then now to get the same denominator as on the left side, so here you need to times with 2x plus 3 squared. For the first term. And for the second term, you already have 2x plus 3, but we need to times with 2x plus 1 together with 2x plus 3 degree 1, because we need degree 2 for the 2x plus 3. Okay, same goes to the last term, c over 2x plus 3 squared. So now we need to times with 2x plus 1. So which means now for both sides, right, I'm getting the same denominator. So once you are getting the same denominator, basically you can just compare the numerators. Therefore, 10x plus 9 equals to a times 2x plus 3 squared plus b times 2x plus 1, 2x plus 3 plus c times 2x plus 1. So to get all the unknowns, just let the factor be 0. Okay, I will let this 2x plus 3 be 0. At the same time, the a and b will be missing in your calculation because they both multiply with 0. So I let 2x plus 3 equals to 0. That means my x is negative 3 over 2. So for the left hand side, you will get 10 times negative 3 over 2 plus 9. So for right hand side, just consider the c, 2 times negative 3 over 2 plus 1. Okay, that means from here, left hand side is basically minus 15 plus 9, which is minus 6. Then the right hand side is minus 3 plus 1, that is minus 2c. Hence my c is 3. Then now I will let 2x plus 1 be 0. That means my x is negative half. So the left hand side, 10 times negative half plus 9 equals to a times 2 bracket negative half plus 3 squared. The second and third term will be 0 because of the 2x plus 1 is already 0. Then from here, you will get 4 equals to 4a. Okay, hence your a is 1. Now to get another unknown, which is a b, just substitute x by any other numbers because we don't have any other factors. So let x be 0. Left side is 9. So a is 1, just direct replace. Okay, now you refer to this equation and replace the x by 0 for all. And at the same time, replace the unknowns, a and c. So I will get 1 plus 3, 0 plus 3 is 3. So 3 squared plus b is not known. So 0 plus 1, I get 1. 0 plus 3, I get 3. The C is 3. Then here is 1. That means 9 equals to 9 plus 3b plus 3. That means 3b equals to minus 3. Therefore, my b is minus 1. Okay, so at last, I'm getting my partial fractions. So this is going to be, go back to here, this step, a over 2x plus 1. So now my a is 1. So 1 over 2x plus 1. And then plus b over 2x plus 3 plus c over squared. So, but then the b is minus. So plus and minus becomes minus. Okay, and my c is 3. So plus 3 over 2x plus 1 squared. So that is my fx. Part 2, hence means use the partial fractions that we have found. Solve this or show this integration equals to half ln 9 over 5 plus 1 over 5. So now here, 0 to 1 fx dx. Refer back to the partial fractions that we have found. That means these three terms. So I will write equals to integrate 0 to 1, 1 over 2x plus 1 dx minus, okay, I split it into 3 integrations. So integrate 1 over 2x plus 3, then plus 3 integrate 1 over 2x plus 3 squared. Okay, so for the first one, I will be using the ln formula. So this is ln fx plus c. Okay, because the degree of the denominator is basically 1. So then, when I use this formula, I will rewrite the denominator. So now my numerator is a differentiation of 2x plus 1, which is 2. To get back 1 from 2, we need to times half outside. Then minus 0 to 1. Now, for this ln formula, if you do not get exactly the same f prime x, you are allowed to times a constant outside. Okay, just a constant. So again, differentiate 2x plus 3, it should be 2. To get 1 from the previous question, that is half outside. And for the last integration, because the power is 2, we have to move up. So plus 3 integrate 2x plus 3 power negative 2 dx from 0 to 1. Okay, and now for the first integration, that is half ln of the denominator. Now here I put a modulus to make sure that it is positive. And then I will consider the limits now. Okay, then minus second term is half ln of the denominator. Third term, I will be using this formula. Integrate ax plus b to the power of n dx. That is going to be ax plus b. The degree now becomes n plus 1 over n plus 1. And when you differentiate ax plus b, that is a, followed by plus c. And this formula is valid when the n is not minus 1. That means now here I will be getting plus 3, copy the function. Instead of degree minus 2, you plus 1, so it becomes minus 1 over the new degree, and differentiate 2x plus 3 is basically 2. And now limits 0 to 1. Okay, so here I will replace the x by 1 now. It will be half ln 2 times 1 plus 1 is 3 minus half ln 5. So basically, when you look at here, this is power negative. That means this whole term I can bring it down. Okay, so this minus and plus is minus. So then 3 over 2 of this term, which is minus 3 over 2. Then replace the x by 1. So 2 times 1 plus 3 is basically 5. Minus when the x is replaced by 0. So I get half ln 1 minus half ln 3. And when I replace x by 0, I get negative 3 over 2. Then here is still have 3. Okay, so from here, since the first term, right, from here probably I can just simplify all the ln first. Ln 1 is 0. So here I can group all this. Now look at here, half ln 3, this when you multiply in, it is plus half ln 3. So it means that I'm getting half ln 3 minus half ln 5, then plus half ln 3. Okay, and then for the constant, it will be these two terms, but then the 3 can be cancelled off. So I'm getting negative 3 over 10, and then this minus, don't forget there is a minus outside. This minus, when you times in, it will be a plus. So I'm getting plus half. Okay, now look at the answer. You need to show half ln 9 over 5 plus 1 over 5. That means here, I must factorize the half from the first three terms. So it will be ln 3 minus ln 5 plus ln 3. And then for the next term, I need to get one term only. So minus 3 over 10 plus half is basically plus 1 over 5. And now, to combine the 3 ln to be 1 ln, as given in the question there, apply the formula. Ln A plus ln B is ln AB. Then after that, ln A minus ln B, that is ln A over B. Okay, that means now here I will be getting half. So ln 3 plus ln 3, I get ln 3 times 3. And then you have the minus here, means divide. Okay, this is what I'm getting. Therefore, when you simplify, that is basically half ln 9 over 5 plus 1 over 5. That is same as the given expression in the question. Okay. Now, next question, number 9. The points A and B have position vectors. That means these two are, this is OA, this is OB, two vectors. The line L has this equation. Show that L does not intersect the line passing through AB. Okay, so now, first of all, I need to find out what is my direction vector for the AB first before I form the line passing through AB. So AB is basically OB minus OA. So my OB is 3, 1, 1. My OA is 1, 2 minus 1. That means you will be getting 2 minus 1, 2. Okay, when you open the brackets. Now, my line AB, the equation always R equals to A plus TB. Okay, this is the general line, general form. So I will write RAB equals to, I can just pick any point. You can write OA or OB, up to you. So TAB. So this is going to be 1, 2 minus 1 plus T of 2 minus 1, 2. This is my RAB. Now to show that L does not intersect, or two lines are not intersecting, so I will let this be the first equation, and then my R equals to, now rewrite this, 2i, 1j, 1k. That means it's 2, 1, 1 plus mu 1j, 1i, 1j, and 2k. So now I will equate them. Okay, so as long as I cannot find the t and mu that satisfy both, all the equations, that will be no intersection. Excuse me. So first equals to second equation, which means 1, 2 minus 1 plus, okay, I open the bracket, direct open, so plus 2t, and then here, when you multiply in, so you get minus t, then plus 2t. It will be equals to, for the second equation, so I get 2 plus mu, then 1 plus mu, and 1 plus 2 mu. Okay, so now I will solve these three equations. Let it be third, fifth, fourth, and fifth equation. So now, to solve these two equations, I can just, to solve these three equations, since I have two unknowns, t and mu, so I just need two equations. Therefore, I will use the third and fifth equation because both have 2t, positive 2t. Okay, or probably I use the third and fourth because I can eliminate the mu. So now I will just write the third minus fourth. Okay, so left hand side 1 minus 2, I get minus 1. Then 2t minus t, it will be plus 3t. Then for the right hand side, 2 minus 1 is 1. The mu will be 0. So then from here, 3t equals to 2. Therefore, my t is 2 over 3. Okay, so now, because I'm solving this t using third and fourth, that means to solve the mu, I have to use back third or fourth equation. So I will substitute into fourth equation to get the mu. So 2 minus 2 over 3 equals to 1 plus mu. That means 4 over 3 minus 1 equals to mu. Therefore, my mu is going to be 1 over 3. So once you have found these two unknowns, remember just now we just used the third and fourth. The fifth is still available. So I will substitute into the fifth to do the checking. So the left hand side, it will be minus 1 plus 2t. T is replaced by 2 over 3. And here I'm getting 1 over 3. Then for the right hand side, that is 1 plus 2 mu. And replace the mu accordingly, then you will be getting 5 over 3. So obviously, the t and mu cannot satisfy the fifth equation because you are not getting the same value. So when you are not getting the same value, line L does not intersect with the line AB. Okay, so we have shown this. Okay, part 2. The plane M is perpendicular to AB and passes through the midpoints of AB. So then, the plane M intersects the line L as point P. Find the equation of M and the position vector of P. Okay, so now, let's say this is the line AB. Right? And there's a plane. Let's say plane pi. So, plane M. So for plane M, I will have normal vector M. And then for the AB, you will have the direction vector AB. Okay, so here is AB. So obviously from here, right, the direction vector of the AB is parallel to the normal vector of the plane M. It's parallel to AB. Therefore, I will say and M equals to AB. So the AB we have found just now. The AB is 2 minus 1, 2. Okay, and now the question asking for equation of the M. Alright, so now it's mentioned that the plane M passes through midpoints of AB. So midpoint of AB, okay, let's say let midpoint of AB be M. Okay, so now I need to find out what is my OM. So this is the M. Right? So for information, when you need to calculate the midpoints of 2 points of AB, so the coordinates, it will be half of the, it will be the average of the X and average of the Y. So same goes to the OM. It will be half of OA plus OB. Okay, so then from here, you will get half of my OA is basically 1, 2 minus 1. and plus my OB from the previous part, 311. Then you will be getting half of 1 plus 3 is 4, 2 plus 1 is 3, minus 1 plus 1 is 0. Therefore, this is going to be 2, 3 over 2 and 0. Okay, that is the point. Now, my M, the equation, okay, vector equation of plane M, that is R dot N equals to A dot N. So, now, the question is asking for find the M. So, the M is basically, you can just write R dot, the N is 2 minus 1, 2 equals to A is the point. So this is the point on the plane. So I will write 2, 3 over 2, 0, dots with 2 minus 1, 2. So for the dots product, you just multiply and plus the components, plus the multiplication. So obviously that is 4 minus 3 over 2. So then you will be getting 5 over 2. Okay, this is the first part. Now, we need to find the OP. Okay, it's mentioned that the plane intersects the line L at the points P. So now I need to find out what is my intersection point. So copy this line L. So now, line L, the R equals to 211 from the previous question, mu 112. So for intersection, just substitute second into first equation. So now I will just write second into first to get the intersection point. Then at the same time, I combine these two vectors. It will be 2 plus mu. Then 1 plus mu, just open the brackets. Then 1 plus 2 mu. That is my second equation. Dots with 2 minus 1, 2 equals to 5 over 2. This is to get the mu. That mu will give you the point the points P, and hence you are getting the position vector of points P. Then from here, you will get 2 plus mu times 2 plus 1 plus mu times minus 1 plus 1 plus 2 mu multiplied with 2 equals to 5 over 2. Then you will be getting 4 plus 2 mu minus 1 minus mu plus 2 plus 4 mu equals to 5 over 2. That means the total for the mu is 5, and then all the numbers move to the other side and combine with the 5 over 2, you will be getting minus 5 over 2. So from here, I know that my mu is negative half, because you can just divide by 5. So now to get the OP, so I will refer to second equation. Okay, that is OP equals to, probably you can just direct refer to this, because that is also the second equation. So I will get 2 plus mu, then 1 plus negative half. After that, 1 plus 2 of negative half. Then you will be getting 2 minus half, that is 3 over 2. 1 minus half is half. Then 1 minus 1 is 0. So that is the position vector of the points P. Okay, now for question 10. The diagram shows a curve y equals to sine 3x cos x for the x between 0 and half pi, and the minimum point M. The shaded region R is given. By expanding sine 3x plus x and sine 3x minus x, show this. Okay, so now I will just write sine 3x plus x, that is sine 3x. We have a formula. sine A plus B. This is sine A cos B minus cos A sine B. Okay, another one is the minus. So when here minus, this is plus. So these two are the forms that we are using. Then here you will get cos x plus cos 3x sine x. Okay, and same goes to sine 3x minus x. This is sine 3x cos x minus cos 3x sine x. Now, you want to show this, so I will start from the left hand side. No, I will start from the right hand side because you are given this is basically sine 4x. Okay, and here is sine 2x. So start from the right hand side. So right hand side equals to half of sine 4x plus sine 2x. So now I will say this is my sine 4x. Then here is my sine 2x. So now I will just rewrite. So that is sine 3x cos x, just replace, plus cos 3x sine 1x. Okay, then plus, for the sine 2x, just refer to the second expression. So now I notice that this minus cos 2x sine x can be simplified with this, right? So means that you only have two terms left. So that means this is going to be half sine 3x cos x, sine 3x cos x, it will be 2 of sine 3x cos x. So the 2 and half will be cancelled off. Therefore, I'm getting sine 3x cos x. Okay, so we have proven the identity. Now part 2, using the result of part 1, show all necessary working the exact area. So area is basically from this point to this point, integrate y dx. But then firstly, I need to find out what is this intersection first. Okay, so this intersection happens when y equals to 0. Alright, so now I will have to solve y equals to sine 3x cos x when y equals to 0. That means either my sine 3x equals to 0 or cos x equals to 0. So sine 3x equals to 0 means that your 3x, you refer to the sine graph. Okay, look at the interval. See your x from 0 to half pi. So from here I will write x, I will write here x from 0 to half pi that means 3x will be from 0 to 3 over 2 pi. Okay, so when you look at the sine graph, so here is 2 pi, this is pi, here is half pi, and this is 3 over 2 pi. Now, when the graph is 0, that means it will be at 0, here is 0, 0 pi and 2 pi. So it means that now, because your maximum value for 3x is only 3 over 2 pi, therefore the 2 pi will not be included. So then from here I will write my x is basically 0, sorry, it's not x, it's 3x because I'm solving 3x, 0 pi. Okay, then from here my x will be divided by 3, so 0 or pi over 3. And then for the cos x equals to 0, right, cos x equals to 0. So then again your x is from 0 to half pi, so refer to the cos graph. Here is 2 pi, this is 1 pi, half pi is over here. This is 1, minus 1 and 0. This is my cos graph. So when the cos is 0, that means it is on this point. Okay, and exactly pi over 2. So therefore my x is exactly pi over 2. Right, so now you check the graph. Where is the intersection? Means that now I will be getting 0, 1 over 3 pi and 1 over 2 pi. So it's already mentioned 1 over 2 pi here. That means this is definitely pi over 3, 1 over 3 pi. And then a 0. So you have to integrate from 0 to pi over 3 for the area of the shaded region. Okay, then from here, I will just write area equals to integrate from 0 to pi over 3. Then the y dx, that is sine 3x cos x dx. And now, sine 3x cos x we have solved just now. That is half of sine 4x plus sine 2x. So here I will change. This is going to be half of sine 4x plus sine 2x. So when you integrate sine, mx plus b. So integrate sine, negative cos. Then divide by differentiation of mx plus b, that is m. Okay, then of course plus c here. So now from here, I will be getting half. Integrate sine is minus cos. Copy 4x over 4 because differential 4x is 4. Plus, or not plus, because you integrate sine is minus cos. So minus cos 2x over 2. Limits 0 to pi over 3. And now just replace the x by pi over 3 first. I will get half of negative 1 over 4, take out the 4, cos 4 times 4 times pi over 3, that is 4 over 3 pi. Then minus the over 2, take it out, it will be half cos 2 over 3 pi. Then you minus when the x is replaced by 0. So I'll get negative 1 over 4 cos 0, then minus half cos 0. So remember, cos 0 is 1. Okay, so now cos 4 over 3 pi, when you multiply with the negative 1 over 4, you will be getting negative 1 over 8. Okay, cos 2 over 3 pi multiplied by half, that is plus 1 over 4. Then this minus, bring it in, it will be plus for both values. So with this calculation, at last, you will be getting 9 over 16. So this is the exact area of the shaded region. Okay, part 3. Using the result of part 1, express dy dx in terms of cos 2x and hence, okay, this is the first part, hence find the x coordinate of the m correct to 2 decimal places. So now my y is sine 3x cos x. It is half of sine 4x plus sine 2x. And now we need to get dy dx. So dy over dx, keep the half. When differentiate sine, okay, differentiate sine mx plus b. Differentiate sine, you get cos. Rewrite mx plus b. And then differentiate mx plus b, that is m. Therefore, you will be getting 4 cos 4x. And same goes to sine 2x, it will be plus 2 cos 2x. Okay, now, dy dx in terms of cos 2x. Okay, but here we have cos 4x, right? So you must change the cos 4x into cos 2x. So now here I will use the double angle formula. Cos 2a is 2 cos square a minus 1, whereby 4x is 2a. So 2a equals to 4x. That means my a is 2x. So which means now here I will be getting half of 4 bracket cos 4x. Okay, so replace the x by 2x. I will be getting 2 cos squared 2x minus 1 plus 2 cos 2x. Then now here, okay, so you will be getting the half and 4 cancel off. Okay, this half and 4 becomes 2, and then this half and 2 cancel off. Alright, that means here I will be getting 4 cos squared 2x, because you have the 2 outside, this 2 you times into the bracket, then minus 2, and then plus cos 2x. So I rearrange so that it is in the quadratic form. This is my dy dx. Now, and hence find the x coordinate of M. So when you look at the graph, the M is actually the minimum point, which means dy dx equals to 0. So now I need to solve dy dx equals to 0 to get the x coordinate of the M. Because that is the minimum point, which means it's also a stationary point. So 4 cos squared 2x plus cos 2x minus 2 equals to 0. Okay, then to solve this, since this is a quadratic equation, I can either remain in cos 2x, or probably I can change it to u. So u equals to cos 2x, therefore I'm getting 4u squared plus u minus 2 equals to 0. And this quadratic equation cannot be factorized, therefore I'm going to use the formula, quadratic formula, which is ax squared plus bx plus c equals to 0. That means your x is minus b plus minus square root of b squared minus 4ac over 2a. Okay, that means now here you will be getting your u is minus 1 plus minus square root of b squared minus 4a. A is 4, c is minus 2 over 2a. Okay, probably I will just write down my a is 4, my b is 1, and my c is minus 2. Then from here, you will be getting u equals to minus 1 plus minus square root of 33 over 8. And now I will calculate two values. So when you calculate using the minus, you will be getting negative 0.84307. And the other one with a positive sign, that is 0.959307. So now refer back, or substitute back into here. So cos 2x is negative 0.84307, or cos 2x is the positive value. Okay, now when you look at the graph here, we know that our M is between pi over 3 and pi over 2. So that's why I need to find out what is my proper M. And then we need to solve these two equations. Okay, so when cos 2x is negative, right? So it means that your 2x, when you calculate the angle in radians, right, that is going to be 2.57376. This one you can just direct calculate inverse cos of negative value. Then now your x is going to be 1.29. Okay, and then the other one, your cos is positive. That means your 2x is going to be 0.93592. Just refer to the basic angle, because from here we know that, right, when you look at the graph, it is between 0 and half pi for your M. So it means that it is in the first quadrant. That means now, okay, so if it is in the first quadrant, by right your x is your x is in the first quadrant, 2x it will be in the second quadrant. So in the second quadrant means that the cos should be negative, but it's okay. I will just solve this first. It will be 0.46796. Alright, so from here you just say the M lies between pi over 3 and half pi. Okay, therefore So therefore, the x must be greater than, therefore the x must be 1.29, because pi over 3 is basically 1.047. Okay, that means you can just write x must be greater than 1.047, or I would say like this, 1.047 x and half pi. Okay, so obviously your x is 1.29. Okay, so that is the solution of this question. And I have come to the end of the video. Thanks for watching. Please like this video and subscribe to the channel if you enjoy watching my video. And also you are encouraged to share this channel with your friends, okay, for all benefits, right? So thank you everyone. Bye.